Hello everyone. In this question we are given that if the integral of 2x square plus 5x plus 9 upon the square root of x square plus x plus 1 dx is equal to x times the square root of x square plus x plus 1 plus alpha times the square root of x square plus x plus 1 plus beta logarithm of absolute value of x plus half plus square root of x square plus x plus 1 plus c, then we have to find the value of alpha plus twice beta. Okay, so this looks very complex and complicated and lengthy, and there is very repetitive terms like the square root of x squared plus x plus 1 is appearing in three of the terms in the answer of this integral. Okay, so let us first start. Before starting, if you look at this format of this integral, okay, this is 2x square plus 5x plus 9 in the numerator, and in the denominator this is also a quadratic term, but it is inside the square root. Okay, so square root of x square plus x plus 1 times dx. Okay, so roughly speaking this is of integration of say ax square plus bx plus c upon square root of dx square plus ex plus f, say. Okay, dx. Okay, so in order to solve for such integrals, the substitution that you need for this is a constant a times this denominator. Okay, this denominator, which is in this case, in this general case, dx square plus ex plus f plus b times the derivative of the denominator. Okay, so there are too many d's here, but just consider this d as this constant. Okay, not related with this ddx. So dx square plus ex plus f plus another constant, capital C. Okay, so there are three constants that you need to find out, okay, after doing the substitution. So let us start with this same method. Okay, we will do this substitution and let us see how what we get after solving. So this is the general format. So similarly here I will do this substitution. So this will become a times x square plus x plus 1 plus b times, I'm doing the derivative directly. Okay, so derivative of this x square plus x plus 1, this will be equal to uh, 2x plus 1. Okay, plus some c. So this should be equal to, sorry, not the integral. Okay, not the integral, the numerator of this integral should be equal to the right hand side. Okay, so slight mistake on my part here while writing this. Okay, the left hand side should not be the integral, we are doing the substitution here. So the numerator is 2x square plus 5x plus 9, right? So this is the substitution that we are using here. The numerator of the numerator should be equal to this. Okay, so after doing this we see that 2x square plus 5x plus 9 is equal to a times x square plus, if we take all the x terms together, right, it will be ax plus 2bx. So this becomes a plus 2b times x, right? And if we look at the constants, we have this a times 1 is a, b times 1 is b, and c times 1 is c. Okay, so the constants become just a plus b plus c. Okay, so now if we equate the coefficients, we get a equal to 2 x square, coefficient of x square. Similarly, coefficient of x, if we equate, we get a plus 2b is equal to 5, and we get a plus b plus c is equal to 9, right? So if we substitute this a equal to 2 in this equation, a plus 2b, we get 2b is equal to 5 minus a, which is 5 minus 2, which is 3. So this implies that b should be equal to 3 by 2, right? Similarly, then if we put these two values a and b, a is 2 and b is 3 by 2, we get c equal to 9 minus a, which is 2 minus 3 by 2. So this means 7 minus 3 by 2. So this is 14, 11 by 2. Okay, so we have found the constants. The constants are a equal to 2, b is equal to 3 by 2, and c is equal to 11 by 2, I believe. Okay, so these are the three constants. So now if we try to solve for this integral, okay, our expression was 2x square plus 5x plus 9, right? So we have 2x square plus 5x plus 9 is equal to 2 times x square plus x plus 1 plus 3 by 2 times 2x plus 1 plus 11 by 2. Okay, so now let us divide both sides with the square root of x square plus x plus 1. Okay, so on dividing both sides by square root of x square plus x plus 1. Okay, this term, this is just the square of this basically square root term, right? So this is just 2a upon root a. So this will be just 2 times square root of x square plus x plus 1, right? Then this is just 3 by 2 times 2x plus 1 divided by square root of x square plus x plus 1, and the last term will be just 11 by 2 upon square root of x square plus x plus 1. Okay, okay, so far so good. Now let us try to do the integral. Okay, so now we'll integrate both sides with respect to x. So 2x square plus 5x plus 9 upon this square root of x square plus x plus 1 dx is equal to 2 times integration of x square plus x plus 1 dx, plus for the second integral, if I take this constant out, this will become 3 by 2 times 2x plus 1 upon square root x square plus x plus 1 dx, plus for the last integral, if I take this 11 by 2 constant out, this will become 11 by 2 times dx upon square root of x square plus x plus 1, right? So if I take this as I1, if I take this as I2 and this as I3, okay, for all these three integrals, different integral formulas will be required. Okay, so if I just write the formula for one time, okay, for I1, this is square root of x square plus x plus 1. Okay, so the formula that will be required is integration of x square plus a square whole thing under root dx. Okay, so for this formula, for this integral, the formula is half times x times the square root x square plus a square plus a square times logarithm of x plus square root x square plus a square, I believe. Okay, this is for I1. Now here this is 2I1. Okay, so if we just do the 2I1, we will just have this part inside the bracket left for this I1. Okay, now I2, for I2, this is of the form, if I take this as u, this denominator as u, okay, then the integral is of the form du upon root u, right? If you do the derivative of this will be 2x plus 1, right? So this is present in the numerator, so this is of the form du upon root u, right? So this will become 2 root u, right? U to the power minus half divided by minus half plus 1, right? So this changes to 2 root u. like ddx of 2 root x is root x, right? So this is the formula. If you want the formula version, this is minus half plus 1 by minus half plus 1. So this becomes u to the power half by half. So this becomes 2 root u. Okay, this will be the formula for this second integral. Okay, and for the last integral, again this time I have to use this formula, dx upon square root of x square plus s square. Okay, so this formula is logarithm of absolute value of x plus square root of x square plus s square. Okay, these are the three formulas that I will use for this different three integrals. Okay, also we have to make this x square plus x plus 1 into a whole square. Okay, so if I try to write it as a whole square, this will become x square plus x plus 1 is x whole square plus 2 times x times half, right? So I have to write this as half square for a plus b whole square. So this becomes 1/4, right? So if I take 1/4 from 1, 3/4 will be remaining, right? So this changes to x plus half whole square plus, if I write this as a square, right? We have this a square here. In all of these terms, there is a square, right? X in our case is just x plus half. And a in our case for all these three integrals will be root 3 by 2 whole square. Okay. So these are the 3 or 4 formulas that I'm going to use for these integrals. Okay. The complete square version of x square plus x plus 1, and these are the formulas I will use for respectively these 3 integrals. Okay, so the required integral I, so we have 2x square plus 5x plus 9 upon x square plus x plus 1 dx, right? We have 2 times this value, right? So if I just cross multiply this, only this part will be remaining, right? But in our case, x should be replaced with x plus half, and a should be replaced with root 3 by 2. Okay, that is our x is x plus half and a is root 3 by 2. Okay, so these are the two things that we have to use in our formula. So this changes to 2 times half times this is x, right? So x is x plus half x plus half times square root of x square plus s square. So x square plus s square is nothing but x square plus x plus 1, right? So this is again just x square plus x plus 1. Okay, because if you just open the bracket, you get this one, right? We have factorized this, so if we open this, we'll get this back. Okay, so this is x square plus s square. So this part is done, and then we are left with plus a square. So a square will be root 3 by 2 whole square. So this is 3 by 4 log of x plus, so again x plus half plus x square plus s square will be again this term, right? X square plus this square root term, x square plus x plus 1. Okay, so this is just I1. Okay, but we have completed it. You see, if you look in this given answer also, this is beta ln x plus half plus something, right? So I think this term is matching. Okay, this 3 by 4 term is matching. Okay, so now let us look into this second integral I2. So I2 is nothing but 2 root u, right? So this will be 3 by 2 times 3 by 2 times 3 by 2 times 2 and root u, where in our case u should be equal to this x square plus x plus 1, right? So this becomes x square plus x plus 1. Okay, This is I2. Then we are left with I3. I3 is 11 by 2, right? So for this will be ln x plus this. So this will change to 11 by 2 times ln x plus half plus square root of x square plus x plus 1, right? Then the plus c for constant of integration. Okay, so now if we start simplifying them, this 2 and this 2 will cancel each other, and then we are left with x plus half times x plus half times square root of x square plus x plus 1 plus 3 by 4 times log of x plus half plus square root of x square plus x plus 1. Then we are left with this I2, right? So this is 3 times square root of x square plus x plus 1 plus 11 by 2 times ln mod of x plus half plus square root of x square plus x plus 1, right? Plus c. So now let us just separate these x terms and these other terms. Okay, so we have this x times this square root x square plus x plus 1, and then we have this half, and then we have this 3 times. Okay, so if I write it like this, half plus 3 times square root of x square plus x plus 1, right? And then this the part inside the logarithm is common for these and this, right? For this and this both are common, so I can just combine them together. So this becomes 3 by 4 plus 11 by 2 logarithm of x plus half plus square root of x square plus x plus 1. Okay, plus c. So I think it is completed now. I believe the format we have achieved the format of the given answer. Okay, given integral. So first term is just x times square root of x square plus x plus 1, and then I believe this is alpha, right? So this becomes half plus 3, which is 7 by 2. 7 by 2 times square root of x square plus x plus 1. And I believe this is beta, right? This coefficient of this logarithm, yes, this is beta. Ln x plus half plus square root x square plus x plus 1. Okay, so this now becomes 3 by 4 plus 11 by 2. So if I double this becomes 22 by 4. So this becomes 25 by 4. Okay, 25 by 4 x plus half plus square root of x square plus x plus 1 plus c, right? So this is alpha and this is beta, right? So we were asked to find the value of alpha plus 2 beta. So alpha plus 2 beta will be 7 by 2 plus 2 times 25 by 4, right? So this becomes 7 by 2 plus this will become 25 by 2. So this is 32 by 2, so which is just 16. Okay, so I believe this is the required final answer. Okay, this was very lengthy question. I don't know if this question is worth solving in the exam. If you require that much amount of time while solving it, I don't know if it is advisable or not. But if it comes in the boards or not, I don't know whether such level comes in board these days. I cannot tell. But if you want to practice this is very lengthy question. Okay, this is what but I could achieve. This was not difficult that much, but it required these formulas, and these formulas were very lengthy. You need to write them many times, and this is very time consuming. Okay, very time consuming and computational sum. These days, NTA seems to be asking such questions which are much more calculative and much more computational. Okay, so this is the required answer. You see if there is any mistake in any of my steps or in my answer also. But I believe this is the required answer. Yeah, while solving, I believe this was the answer. So you see if there is any mistake in any of my steps, or if you know any shorter methods, you can highlight in the comments. Okay, so this is the required answer. Thank you for watching.